Okay, people, talk to me. Yeah, you said yesterday, that you were having trouble resolving between what you came up with and what Wolfram Alpha gave you.
Yeah. So like for 4.9.
Y double prime plus Y equals secant squared X. Y of pi is 0, Y prime of pi is 0. Right?
That's 4.9.
Oh, I'm looking at the wrong section. That's for 4.8, which is on the same page as the start of 4.9. So I'm definitely looking at the wrong problems. 4.9, here we go. Number 18. Systems. Dx plus z equals e to the t. D minus 1x plus dy plus dz equals 0. And then x plus 2y plus dz equals e to the t again. Okay. Talk to me about what you did.
I solved the first, right? I took the derivative of the first equation.
So I get d squared x plus dz equals e to the t.
And then I solved that for d, plugged it into the third equation.
Which is going to give me something that's just an x and y, right?
Yes.
So dz is negative d squared x plus e to the t. Put that in here. I get minus d squared plus 1x plus 2y. And then the e to the t cancels and I get a 0. So now I have an equation that's just an x and y. Okay. What else can I do?
So, and then the derivative, and then plug those two that I have into the second equation.
So you get dy from this.
Yep.
Okay, so 2y equals d squared minus 1x. So 2 dy equals d cubed minus dx. I'll put a 1/2 in front of that. And now this and this are both going to go in there. D minus 1x plus 1/2 d cubed minus dx minus d squared x plus e to the t equals 0. Yes? Which is a third order differential equation in just x. 1/2 d cubed minus d squared. I got a minus 1/2 a d and plus a d right there. So that's going to give me plus 1/2 d minus 1 x equals negative e to the t. Disgusting. But what do you do from here? Lots of choices.
And I did my R region.
I got to solve the homogeneous one before I can solve the non-homogeneous one.
I multiply everything by 2 first. And then I got R equals 2 or plus minus 1.
So that means I should get the corresponding homogeneous solution is e to the 2t, c1, e to the 2t plus c2 cosine t plus c3 sine t, right? Great, wonderful. Now I need to deal with that e to the t. But since there's just e to the t and e to the t is not part of any of this, I say that yp should be of the form a e to the t. So then all of the derivatives are the same thing, aren't they? So I get 1/2 a e to the t minus a e to the t plus 1/2 a e to the t minus a e to the t equals negative e to the t. I took all the derivatives and put them back in here. And at this point, I realized that this should be x, not y. xc, xp. Big deal. Just changes the label. And so I get, let's see, I get negative a e to the t equals negative e to the t because I have plus 1/2 minus 1. So I get a equals 1. And that means that x is c1 e to the 2t plus c2 cosine t plus c3 sine t plus e to the t. What did Wolfram Alpha give you that made this look much weirder?
constants in front are just like weird, like. You know,
Yeah, I was just saying that. Okay, so I think what's happened is that they went back to find the other pieces, yes? And when they go back to find the other pieces, we're going to get 2c1e to the 2t, right? Because I'm going to have to take the derivative of x twice to get z. No, I'm going to have to take it once to get z. And that's also going to cause me to have a different coefficient on e to the t, yes? I think what they've done is they solved for something different first. Instead of solving for x of t first, they might have solved for y of t first, or z of t first. And then their coefficients are different because of the order in which they've done them. I bet if you multiplied those things out and regrouped, you'd get the same thing. But that's the problem with the computer algebra system, is I can't force it to do it in the same order and fashion that I did. But I still see an e to the 2t, a cosine t, a sine t, and an e to the t in all of my parts, don't I? I'm pretty sure you've got equivalent answers. We just have to go through and verify the coefficients. Phooey. For the record, when I did this in a different fashion. I didn't do a substitution at all. I did the whole thing using elimination. So up here, where you said I'm going to multiply by d and then rewrite, I just took these two, multiplied this by minus d, and added. And wouldn't that give me the same result right here? So it's an equivalent statement. Better? All right. Yes, sir.
For step 6, how can you use matrices to solve it? So I was trying to solve 2, and I was looking up in the online, and when you do the Laplace transforms and like the SYSs and XYSs, it uses the matrix to use to determine it.
Yes. Okay.
Yeah.
Give me the resulting final equation you have, where you have two equations in LS and LX and LY.
We have x equals top, it's s, and in parentheses 1 plus 1 over s minus 1.
Okay, say that again.
It's a lot.
It's in parentheses. No, give me the stuff up there.
These?
Yeah, give me the equations.
It was s x, too many s's and x's together.
Yeah, it's a pain in the ass. So I get S Laplace transform of x minus x of 0 equals 2 Laplace transform of y plus 1 over s minus 1. And then I get s Laplace transform of y minus y of 0 equals, is that an 8? Yes.
Yeah.
8 Laplace transform of x minus 1 over s squared. Okay. Here's the fun part. If I want to think of this as something that I can do a matrix with, what was x of 0? Okay. And y of 0?
Awesome.
Great. So I get s lx minus 2ly, move that over, equals, move that over, I get 1 plus 1 over s minus 1. Yes? Down here, I get negative 8 lx plus s ly equals, move the 1 over, minus 1 over s squared. So far, so good? Okay. S times the first variable minus 2 times the second variable equals this stuff over here on the right. -8 times the first variable plus S on the second variable equals all this stuff here on the left. That's a matrix. Yes? Okay, linear algebra class. Tell me what Kramer's rule does. Kramer's rule does the same thing our Wronskian does. But all I could do is I could take the reduced row echelon form of this. And if I get that, then I'll have L of X equals whatever ends up on this side. I'll have L of Y equals whatever ends up on this side. But there's going to be some more 1 over S's. And some division by S and some weird multiple. So it's going to be a bunch of algebra between here and there. But yes, I get a determinant. Is it fun to do it this way? Only if you really like variable matrices.
So I was thinking, like, we had to solve for like A, B, and C
Yeah.
partial fractions. I like the matrix.
Oh, you can absolutely do that in solving the partial fractions. You can do it here too. But the algebra is messy.
So when you do this, you still have to end up doing partial fractions though?
Yes, because you're going to get LX equals thing. And you might not have that already broken up the way you want it. It does not short circuit the process. Darn. See, because my first reaction is I want a 1 here. So I'm going to divide by S. So I get 1 minus 2 over S. And then here I get 1 over S plus 1 over S, S minus 1. Yeah, I'm going to have to do partial fractions within this, aren't I? So is it any easier? No. It's not any harder, but it's certainly not any simpler. And if you really like matrices, absolutely you should do this way. Because everybody loves matrices, right? Yeah. Linear algebra is the most fun you can. Yes.
For the first one, number 8, it just says construct a mathematical model. That means we have to like solve it, right?
Correct. Just come up with the set of equations that you think models that system.
And then for 10, says without solving it, predict the limiting values.
Yep. Sure. I just want you to think for a second about what's happening in problem 10. There's salt in tank A. There's salt in tank B. There's salt in tank C, right? Talk to me. What's going in?
Nothing.
So what's eventually going to happen to all the tanks? They should eventually have no salt in them, shouldn't they?
I was gonna say it's simple. I just put the middle, like X1.
X1 of T, X2 of T, and X3 of T. Now justify that with your model. I love this problem. Literally because there's no work involved in actually figuring out what's going on. And I've done this. Okay, I'm a sick mother. I work retail food establishments, customer service. You got to mop at the end of the night, right? Got to mop all the floors. Well, this was a big restaurant, so there were like 5 of us doing mop duty. At the end of the night, you have to clean the mop buckets. So I told her, bring the mop bucket. I just rinsed mine, dumped mine in the next, and we just kept dumping them all the way down. Eventually, they were all clean, right? Except I dumped my dirty water into the second one, and that dirty water into the third one, and the fourth one. That's what we're doing with these tanks, aren't we? We're taking what comes out of tank 1, which is salt water, but it's less salty than when it started, putting it into tank 2, which therefore gets less salty, putting it into tank 3, which gets less salty, and eventually, all the salt's gone. They do this with tanker trucks to clean them out between loads. Rather than just run clean water through every tank, if they were all carrying the same stuff to begin with. You can't do it if they're carrying different stuff. Cross-contamination of the chemicals, sometimes it goes boom. You don't want to do that. You don't rinse the salt truck into the milk truck. It's a bad idea.
The other day we were talking about like we use.
I forgot my tool.
What were we talking, basically what we use about this model school.
Oh, yeah.
Could you give me a couple, like, I know you were talking about highway A and C.
Yeah. So,
Is that because the vibration between the two?
in a sense, yes. When I go back and I think about a coupled spring like that, instead of thinking of a pendulum as a string with a ball on it and then another string with another ball, think of them as solid rods. And then there's a joint in between the two rods, right? If you swing the top one, it's going to cause the other one to swing, but there'll be a little lag in the motion. So what happens is I can think of the top weight, the top floor, as being shook by the second floor, as being shook by the first floor, because the ground underneath it is shaking, right? So mass one starts to shake. Let's assume for the moment it goes to the left. So this mass goes left. The one on top of it's going to be like it went to the right, isn't it? But then eventually the pendulum is going to pull it and it's going to. So what happens is they all start to go like, and you get that sort of flick motion at the top, right? And if that flick is big enough, it'll break something off.
I actually got a presentation, I gotta use mathematics and how we use it, or how we, or what's mathematics and what.
I'll give you the absolute most amusing version of this. Do you know what the first object on the face of the earth was to break the speed of sound? The first man-made, man-controlled object to break the speed of sound?
The jet.
Nope. You're several hundred years too late.
Rock.
No.
Networks.
Say again? Your vocal cords break the speed of sound?
Is it like a whip or something?
The crack of a whip breaks the speed of sound. That's what the crack is. It's the sonic boom of the tip of the whip. That's why a whip starts out large and gets narrower as you go to the tip. That first bit of movement causes the next piece to move. The next piece is lighter, so it moves a little faster. The next piece is lighter, so it moves a little faster. And it uncurls. And by the time all that momentum is in that little bitty tip of rope, which is basically thread at that point, it goes and clears 750 miles an hour. Sorry, 732 miles an hour, speed of sound. Mach 1. First thing to break the speed barrier, speed of sound, was a whip. But it's this differential equation. If you think of each piece of the whip as a separate little rod, which by the way, they do, because they make whips out of chain links. And chain whips behave exactly like a series of pendulums. Okay, as soon as I get back to my office, I'm putting the toy in the box. Here, I'll do it the easy way. The original toy is called an Astro Jacks, and it is literally two balls, one tied to each end of a string, and the middle one floats. So what happens if you hold one end with two balls and one end with one, and you let go of the double end? Well, the two balls start to fall together, right? But if you first let the middle one float on the string, then you get a two pendulum. And that two pendulum behaves very differently. Where is the video? There used to be a video on here. Ah. I actually have two differential equations papers on the motion of an astrojet and the motion of a double phantom. I'll bring it. I'll bring it, I promise. Anyhow, more questions.
The last question.
You can go as many as you want. I'm not limiting you here.
The circuit one, number 14, was confusing me. Cause you had to like show it, and I was looking at an example in the book and it just,
Which section?
uh,
Circuit. This one? Okay. So let's think about what is happening with current 2 and current 3. Because it's only asking me about I2 and I3, right? Okay. When I think about a piece of current, I really think about 3 different results. Now, here's an electrical engineering piece or a Calc 3 piece or a complex variables piece. My buddy Kirchhoff told me that all the current that goes into a location must be equal to the current that goes out. So let's pick a joint in my wires. How about the one at the top? What's going in is current 1, right? What's coming out is current 2 and current 3. So I know that I1 has to be equal to I2 plus I3. That's the junction rule for Kirchhoff. The other thing I know is about loops. So let's look at the loop here and the loop here, because those are 2 wire loops. If I look at the loop on the left has a battery, a load, and a resistor. That's an RL circuit, resistor and load. So I start to flip back to 3.1, where we did circuits, and I have this rule about resistors and loads. And so I'm going to say that this is my resistor load equation for 1. And I look back at this picture and I say to myself, the current that goes through the load is I1, but the current that goes through the resistor is I2. And then we get back to the electrical force, the electromotive force. So if I go back to that equation here, the current that goes through is up. That's going to be di1 dt. Resistor goes with which current? Is equal to E. The loop on the right has resistors and capacitors, right? But no load. So that means I can use this one for RC circuits, resistors and capacitors. I'll use this equation.
Can you like draw the loop? Is it the outer loop or is it?
No, I'm using this inner loop right here. Now notice the current is going this way, but when I go around the loop, I'm going the other way. You need to put a minus sign on that. Okay. The current is going down, but when I do the loop, or I could do the loop the other way, in which case I'd be going up for these pieces, wouldn't I? The current is going down on both sides. I got to be going up on one side. So one of those is going to get a minus sign. Depending on which book you read, some books will tell you should always go counterclockwise. Hey, I remember that. That's trig. I should always go counterclockwise. Okay, if I'm going counterclockwise, then I'm using this orientation. And that means that this current, because the current wants to go down and I want to go up, that gets a minus sign. If I go clockwise, then I do it the other way around, and this current is going down when I want to go up. But the total drop, Kirchhoff's laws say, the total drop on a resistor capacitor side is 0. So it doesn't matter which side gets the minus sign, as long as one of them does. Now, my current problem is that the set of equations I come up with involve I1, I2, and I3. And they want me to show an equation that just has I2 and I3 in it. But what did you tell me about I1 and I2 and I3 together? So everywhere I have a derivative of I1, I can replace it with a derivative of I2 plus the derivative of I3. And that means in spite of the fact that I think this should be 3 equations, it does eventually just become 2. Whew. Now, here's an interesting point. If I think about what this circuit does, let's think about this as a light bulb. This L, that's technically what that symbol is. It's the coil inside a light bulb. So the charge starts moving through it, lights up the light. Then the current splits and is slowed down by my resistors, yes? So only some of the current comes back here. It's been slowed down a bit. Some of the current goes here and starts to build up on the capacitor. Capacitor is 2 little separate metal plates with a space between them. And as electricity builds up on the top, after a while, it creates a spark and jumps the gap. And all the electricity drains out then. So what happens is the light goes on, and the current comes through and the light starts to dim as the charge builds up on the plate, and then the circuit pops, it discharges to the other side of the plate, gets back around, and the light gets bright again. This is a flashing light. Boom, 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 boom. I don't know what any of the numbers are, but the numbers for the resistor and the capacitor and the load will tell me how fast it flashes. And if you end up solving this equation, you'll get a periodic function with decay on it. Exactly what I would expect from a repeating flashing light. Which means there's got to be an imaginary root in there somewhere for me to get the cosine and sine pieces. I am not an electrical engineer, nor do I play one on TV. I just learned a bit when I blew stuff up. And you can do that too. Take physics 2. That was one of the labs in physics. Blow up the resistor, show that the resistance is nonlinear after a certain point.
Is that Kirchhoff's?
Mm-hmm. Which is, by the way, a variation of Green's theorem from Calc 3, which makes it Cauchy's integral formula from complex. It's the same setup. One class teaches all the subjects. More questions, ask me more stuff. At least I hope that's what that circle does. You should build it. I wonder how upset Dr. Bogdan would get if I went into the lab and started showing stuff. Yes.
So for number 2 for 13th grade, it says to graph all the equations on a non-singular
Uh-huh.
plane.
Mhm.
I think I'm doing it, but I don't know. We use Desmos right now.
Well, you're getting a really complicated looking set of x of t, y of t, right? I mean, the numbers aren't simple.
Yeah, and the three different lines are all like crossing each other.
Yes, absolutely.
And then it's also like determined half-life.
Ah, so determine the half-life. And it makes sense for the lines to cross each other, right? Because the amount of the potassium decreases over time, and the amount of argon and calcium. Oh, no, this is, they just give us X, Y, and Z, right? So the X, Y, and Z, so the amount of X is going down, the amount of Y and Z is going up, isn't it? But Y is also going down over time. So X starts to decrease. At some point, I don't know what's your X of 0 from your graph? Just ballpark.
Like 20.
Okay, well then at some point it's going to be 10, isn't it?
Yeah.
Tell me what t value that is. That's the half-life. Oh, there you go. And now for element y, you can figure out something similar. But it increases for a while, right? After a while, it stops increasing. It levels off and starts to go back down.
Yeah.
So once it starts to level off, we should be out of x.
Yeah.
So you know where you are when you're out of x. Tell me when you're half that.
Like as soon as it passes X and then gets to the peak.
No, once x is gone,
Oh, okay. So,
once you run out of x, all of the x should be converted into y, right?
yes, but X goes in the negatives. So it's like, I don't know, this is just.
I didn't think x should go into the negatives, but I could be wrong.
I could have, I mean, I could have put them on.
That would be bad. Da-da-da-da-da.
I'm not even sure if
I got pictures that look like this.
kind of looks like that, but it's not.
X is in blue. See how X is getting smaller all the way through. Y starts to come up in green, peaks out when we run out of Y, we start to decay, right? Because we're losing Y. So let's go to at least this point where I know I'm out of X. And start to work your way down and say, okay, well, here I'm at, I don't know, 16 and change.
Yeah.
How long does it take me to get to 8 and change? That's my half-life for that one. X, if I go from 20 down to 10, how long does it take? That's the half-life of X.
Yes. I could.
Or you have a different scale, because I obviously went out way far on the X-axis.
Well, you can visibly see that mine, my X goes in the negatives.
Then yes, something is wrong. Because the amount of X should never get negative. X is a real physical object, right? I can't have negative uranium.
Yeah.
I'd like to know where you get that. I'd like to give it to some people so they lose their uranium. Wrong button. Bonk. So there must be an error somewhere in the equations you solved to end up with a negative value there.
Could it be possible that I put it in the graphing?
It is, yeah, absolutely. But we'd have to sit down and drag through that, looking at each equation. And they are not simple equations because the two different x's and maybe then try looking at the graph in slopes. Because you could actually do the differential equations graphs in slopes without solving them, right? And then you could get the information with that, and then you could check that your equations actually match that picture. That might help. Slopes. Bunk. So systems, I have three equations here, right? My first equation is what's x prime equals what's dx dt?
I solved it.
Well, no, let's go back before we solve it. If I go back to the beginning, the example says dx dt equals negative lambda 1 times x, right?
Yeah.
So lambda 1 is point.
Is it the K value?
Yeah, the k value is given as negative, so I'm okay with that. So the k value is negative point, oops, negative point 138629 x, and x0 was 20. Right? So there's that equation. And that's decaying the way yours was, right? Now let's look at y prime. The setup says y prime equals the same number, now positive x. So 0.138629 x minus the second number, minus 0.004951 y. And y of 0 is 0. Done. Now z. Z equals, and we use the positive number from the second part. Z equals 0.004951 y. And z of 0 is 0. Done. Now I'm going to change the axes. So I go here to settings. Maximum t is going to be 100. Maximum xyz is going to be 30. Let's see. My x of t is in red here, and it's going pretty close to 0. I'm pretty sure I don't need to go above 20, so let's change that x value to be 20. Let's make this t value longer, say 200. I see that spike in the green. You see that if your equation, this is without solving it. So if your equations don't graph out like this, yes, you made an error in putting it into the calculator. That's the thing I like the most about slopes is I can write the equations, get the picture, and then I can do the math and make sure I got the picture right. Or I can use the picture to make sure I got the math right. And as long as I put those equations in there correctly, as x and y and z, I have a model. Now Z is our stable isotope, so that's the one that doesn't decay. That's why it's got a positive coefficient and only a positive coefficient. X is strictly decaying. X decays into Y, but Y also decays into Z. That's why X's coefficient is only negative, but Y has one positive and one negative. It's gaining Y atoms from the decay of X, and it's losing them to the decay of Z. And that's why it starts out growing so quickly, because X is decaying a lot faster than Y is decaying into Z. What was the example in the text? Uranium to thorium to lead, something like that. Yes. Uranium to thorium to lead. Oop, doesn't help. You can't see squat because I'm still screen sharing. Uranium to thorium to lead. That's our uranium decay series. My great uncle. Daniel Sassmore worked on field tech manuals at Los Alamos. So there is a paper that was declassified in the last 15 to 20 years on uranium decay series with his name on it. So it's the only reason I know an inch, because I had a family member there. But my great uncle Danny was 30 years older than my grandfather, so he's been dead a while.
They know about the, like, new effects to uranium.
I'm sorry?
They didn't know about the negative effects.
Oh no, that was the whole point. That was the Fermi pile at the Los Alamos Nuclear Laboratory was developing atomic power. They knew it was dangerous as hell, but that's why they stayed way back from it. But that's uranium-238 emits helium nuclei, alpha particles. And those alpha particles contain 2 neutrons and 2 protons. And so U-238 decays into another isotope. The emission is hot, meaning those particles carry a lot of energy. So how do you moderate that? You take something that's good at absorbing neutrons and not letting them go, and that's cesium. So you take a control rod made of cesium, push it into this uranium, and it absorbs the neutrons, so they're all nice and slow. And when you pull that rod out, it lets more neutrons go, and the pile heats up. And it's that heat that they use to heat water. That hot water creates steam, turns a turbine. That's exactly the way a regular power plant works. They're just using uranium to heat the water. And so there are actually 2 sets of waters. There's the water that touches the uranium, and it's in a tube surrounding the cold water that runs the turbine. And so the steam comes out the top, runs the turbine, condenses. That loop never gets irradiated. Only the uranium hot water loop gets irradiated. I recommend the YouTube video by a guy by the name of Destin. The channel is Smarter Every Day. He did a tour of a nuclear power plant to find that. It's a wonderful, wonderful discussion. They actually show you the tank, the cooling tank for the uranium. It is behind a piece of glass that is 1.5 feet thick. It's ridiculous. It's a porthole. You can stand on it, look down. When you turn it on for the very first time, the speed of the neutrons, I talked about breaking the speed of sound. The neutron reaction is so fast, it breaks the speed of light. And the irradiation snaps through. As those neutrons move so fast, they create waves like the shock waves in the air. They create it in the water. And this lovely blue ripple goes through the pool. It's called Cherenkov radiation. But it's the irradiation of the water is so powerful it emits visible light. Do you know what else did that? The warp engines in Star Trek. They did it on purpose. They made the startup sequence create that same blue flash to show you it was powered up like a reactor. The sci-fi geeks are strong. Anyhow, I've wandered well off the topic.
Figured it out.
Yay! You dropped a parenthesis somewhere, right?
I put in the graph, I put the equation for x equals 20, whatever it is. And that's when I went negative, and I put y, and then fill in the line.
Yes, have to have the right variable in there. More questions. Perfect. Yes,
Yep, K, well, should we have a K or?
for which one?
Or-
No, I should be able to go back and look at the derivatives and solve for that K.
So if I did a K, I have to.
Yes,
Yeah.
you as well. So what I think what you're doing is you're doing the integral at one point. So if you're doing the integral, yes, you need to go back and solve for that constant integration. Take the answer you got out, put it in the other equation, and see what you get.
Wait, say that again?
Take the answer you get out, put it in the other differential equation. Yeah. And put it back in to the other equation here, right? And then go back into the other one, whichever one you used to get the equation, go back to the other one. Take the derivatives to match it, and then make sure that those two line up. We did that in class. We took the derivative of the equation, said, hey, in order for this to work, this K has to be 0, or this K has to be 1. We'll be able to figure out what the value of K is. It'll probably be something to do with C1 and C2. Since we don't have initial conditions in this problem, it'll probably end up having to do with C1 and C2. But that's because there weren't any initial conditions given there. This is why you should all be tutoring Calc 1. So that you go back and you're like, oh, this is easy. And Calc 1 people are like, ah. And you're like, no, this is easy.
So for on the graph, if my new x of 0 is say 50, it'd be 25.
Right. Just measure until it's half the other one. But I think it gave me x of 0, didn't it?
Yeah.
Okay. So it gives me x0 equals 20. I better have 20 at the beginning. Because remember, we start out with no y and no z. We start out with all x. So I better start with 20. And there's no way to make X out of this decay chain. X turns into Y turns into Z, nothing turns into X. Yeah, the amount of X never increases throughout this entire process. It starts with I.
Yeah, you know, type this. Because what I do, like, this is like what
Yeah,
the answer is.
so that should be 20.
Just
Said X equals 0.
so, but this stays there, right? Like, there's should flatten off instead of
That's this equation implied.
yeah. I don't know. I don't know if it's just Desmos or
Let me turn off the other two. Okay, hang on a second. How do you tell me which axis is which? I think you got X and T reversed.
so it's like T equals 20e to the
No, I think this graph, this is the X and this is T.
oh.
How do I set that? What are my settings? This settings for T. Should be labeled. Should be labeled. Should X. That should. T. Yeah, see? You got that as T,
Mhm.
that is X, that's right. Right. X axis T. Graphing that is X. No. Because you told those graphing is X.
So we got this T.
No, it should be graphed as Y. You're doing all of these as Y.
Oh, okay.
All of these are Y.
So then,
Because you've got Y, X, right?
but shouldn't then my graph hit X of 0 at 20? Oh, because that's the X. Okay, that makes sense. All right.
Yes, it was Desmos, but it was also us.
Yeah.
Yeah, this axis, the problem is that Desmos is dumb. And it thinks it's only got two axes. It's got an X-axis and a Y-axis. The fact that you gave it stuff in T confused me. And it graphed this like it was T.
So then that screws up my thought process for plot.
But it now looks much more like this, doesn't it?
Yeah.
Okay, good.
So it would halfway from Y would be from that peak.
Right, from whatever that peak is down to half that peak.
So it's
Or you could pick another value, right? So for example, I know on my picture right about here, I'm at 15. Right about here. Yes?
Yep.
So I can then ask, well, when do I get to 7.5? Because half of 15 is 7.5. That's my half-life. Or I know I'm at 16. When do I get to 8? There are fainter grid lines on the back here. It's not just every 5, but they're really faint. They don't show up quite as well on the picture up there. Wonder if that'll change if I make it a little darker. Yeah, no. Still can't see the background of it. There's another grid in here. I can see it on my picture, but I can't see it up here. Stupid contrast. Never mind. Okay, I'll never mind.
And I'm just finding that for X and Y, right? I'm finding that for Z.
Because Z doesn't decay, does it?
No,
Z always increases.
Yeah.
Z is our stable final element. We go from X to Y to Z, everything Z only accumulates. Talk to me, Mia, something's bugging you.
It's only when it starts decreasing, is when you,
I think it's always easiest to measure it once it's, because then you're not adding anything that will take longer to decay. So I would only measure the decreasing portion of the graph. But you could pick any 2 points. Well, any 2 visible pieces, measure a Y value, measure half that Y value. You could do that at any place in the decreasing section of this graph. And that's why I pick like big grid lines 30. Oh, it's at 15 here. Let's go to 7.5. You could also do it graphically, couldn't you?
with
You
my,
could put 2 horizontal lines on here
yeah,
and ask for the intersection. Because you're in Desmos, you can do that.
yeah, I gotta figure out how to work out this.
Ah,
Have a good day.
well, we'll see about getting some Desmos classes.
Yeah. Have a good day.
You too. Ask me more things. Anybody have another question? All right, then you keep working. I'm gonna shut this thing. So that's all. I got another 10 minutes of your time. I don't want to throw you out. I don't want to run you off, but rather than stand here in silence on a static screen,